Question 1. The question is, explain briefly on the concept of compound interest, a list of formulas that can be used in compound interest. Question 1. The concept of compound interest. Compound interest is a type of interest that is calculated on the original or principal value and the accumulated interest from previous periods. It is also known as interest on interest and can help your investments grow at an accelerated rate. In simple interest computation, the interest is calculated only on the original amount of the principal, which does not change over time. However, compound interest computation is based on the principal value, which changes over time according to the compound interest rate. This means that the interest earned on the principal amount is reinvested, increasing the principal value and earning even more interest. There are also some important terms that you need to know in this topic. Firstly, P is the original principal. Second one is N, which is the number of interest period. M is the frequency of conversion. We also have interest rate denoted by K and periodic interest rate denoted by I. List of the formulas that can be used in compound interest. First one is future value formula. It is S equal to P in bracket 1 plus I in bracket with the power of N. We can also find the value of compound interest by using the formula I equal to S, the future value, minus P, the principal value. To find the amount of the future value, we must use the formula P equal to S in bracket 1 plus I in bracket with the power of negative N. From the formula above, we can find the value of I and N. To find I, use the formula I equal to K over M, where K is the interest rate given and M is the number of interest period calculated in a year. The last one is the value of N, or the number interest period. To find N, we can use N equal to M times T, where T must be in years.
Question 2A, 28,007 ringgit and 25 cents was deposited in a savings account with the interest rate of K% compounded monthly. After 5 years, the accumulated amount in the account worth 32,529 ringgit 64 cents. Find the value of K. We got some information from the question, which is the S was 32,529 ringgit 64 cents. The P was 28,007 ringgit and 25 cents, and the M was 12 because it's compounded monthly, and the T was 5, and we have to find the K. To solve this problem, we have to use S equal P 1 minus I to the power of N as the formula. But before that, we have to put the value of I and N. To get the I, we have to divide K with M. Since we don't have the value of K, we just put K over 12. And to get the M, we just make it 12 times 5 equals to 60. And we put the value into the formula. Then we can start calculate. First thing first, 32,529 ringgit 64 cents divide with 28,007 ringgit 25 cents equals to 1.161472119 equals to 1 plus K over 12 to the power of 60. To eliminate the 60, we have to change it as 1.161472119 to the root of 60 equals to 1 plus K over 12. So the answer we'll get as 1.0025 equals to 1 plus K over 12. After that, 1.0025 minus 1 will get 1 over 400 equals to K over 12. To get the final answer, we take 1 over 400 times 12 and we got the final answer as 3%. Let's move on to the next question. Question 2B. Isma had a farm worth 50,000 and planned to invest the money in 2 different schemes. Scheme A pays 5% compounded every 4 months and Scheme B pays 3% compounded semi-annually. Considering 7 years of investment, which scheme gives more profit to him? To get the scheme answers, first we have to find the value of I and N. To get I, 0.5 over 3 will equals to 1 over 60. It will be the I. And for the N, 3 times 7 equals to 24 and it will becomes the N. So we use the S equal P, 1 plus I to the power of n as the formula. We just calculate it as 50,000 1 plus 1 over 60 to the power of 21, and you will get the final answer as 7,749 ringgit. For the scheme B, we also use the same formula, but we change the I and the n. The I will be 0.015 and the n will be 40. So if you put it in the formula, you can get it as 50,000 1 plus 0.0015 to the power of 40, and it will equals to 61,587 ringgit and 79 cents. So the conclusion is scheme A gives more profit to ISMA than scheme B.
For the next chapter, we learn about annuity. What is annuity? Annuity is a series of equal payment made at equal interval of time. For example, short rental. We pay the same amount at the end of every month. In each case, equal payment are deposited or paid periodically over time. So, what are the important formula in this chapter? We have 3 important formula in this chapter. First, future value, which is S. S equal to R in the bracket 1 plus I to the power of n minus 1 over I. R stand for periodic payment, I stand for periodic interest rate, and stand for number of interest period. The second formula is the interest earned or charged, which is I. I equal to S minus NR. S is future value and R is total payment. The third formula is present value, which is A. A equals to R, 1 minus, in a bracket, 1 plus I to the power of minus n over I.
For question 4A, Sharif deposit RM 26,519.59 in an account. He was offered 4% monthly compound interest at the end of each month. How long can he withdraw RM 250 from the account at the end of each month if he started doing so at the beginning of this year? So we got some information from the question, which is A is 26,519.59, K is 4%, M is 12, R is 250, and we have to find the T. I equal K divided by M, which is 0.04 from 4% divided by 12, and we got 1 divided by 300. For N equal MT equal 12T. To solve this question, we have to use formula A equal to R in bracket 1 minus 1 plus I to the power of negative n divide with I in bracket. A is 26,519.59 equal to 250 in bracket 1 minus 1 plus 0.04 divide 12 to the power of negative n divide by 0.04 divide 12 in bracket. So we got 106.07836 equal to 1 minus in bracket 1 plus 0.04 divide 12 in bracket to the power of negative divide by 0.04 divide by 12. Then we got 0.3536 equal to 1 minus in bracket 1 plus 0.04 divide by 12 in bracket to the power of negative n. 1 plus 0.04 divide by 12 to the power of negative n equal to 0.6464. After that, negative n log 1.0033 equal to log 0.6464 n equal to log 0.6464 divided by negative log at 1.0033 and is equal to 132.4413. Then m equal to mt 132.4413 equal to 12t. T equal to 132.4413 divided by 12. So t equal to 11. For question 4b, Sulaiman bought a house by making a down payment of Rm 52,000. The balance was borrowed from a bank which charged interest of 6.5%, compounded monthly from 25 years, with monthly payment of Rm 987.16 cents. 1. Find the amount of the loan. 2. Calculate the interest paid for the loan. 3. If Sulaiman failed to make the first 7 payments, how much should he pay on the 8th payment to settle all the outstanding arrears? For question 1, find the amount of the loan. R equal to Rm 987.16 cents. T equal to 25 years. K equal to 0.065 and M equal to 12. I equal to K divided by M, which is 0.06 divided by 12. For N equal MT, which is 12 times 25. To solve this question, we have to use formula A equal to R in bracket 1 minus 1 plus I to the power of negative n divide I in bracket. To get the A equal to R in bracket 1 minus 1 plus 0.065 divide by 12 to the power of negative 300 divide 0.065 divide by 12 in bracket. Then we got 987.16 cents in bracket 148.1026946 in bracket, and we got the answer is Rm 146,201 and 6 cents. For question 2, calculate the interest paid for the loan. The formula for this one is I equal to NR minus A, 300 in bracket 987.16 cent in bracket minus 146,201 6 cent, and we got the final answer is Rm 149,946.94 cent. For question 3, if Sulaiman failed to make the first 7 payments, how much should he pay on the 8th payment to settle all the outstanding arrears? The formula for this question is S equal to R in bracket 1 plus I to the power of n minus 1 divided by I in bracket 987.16 cent in bracket 1 plus 0.065 divided by 12 to the power of 8 minus 1 divided by 0.065 divided by 12 in bracket. The final answer for this question is Rm 8,048.63 cents.